Question 6. Which of the following statements is not true of the correlation R between the lengths in inches and the weight in pounds of a sample of brook trout? Okay. So option A, R must take a value between -1 and +1. That's a true statement. That's just one of the properties of correlation. Okay. B, R is measured in inches. All right, so I mentioned in an earlier video for one of the other questions on this test that correlation, or R, is a unitless number, right? It does not have any units associated with it. Okay, so this is a false statement. Okay, C, if longer trout tend to also be heavier, then R would be greater than 0. Sure, right? If longer trout are heavier, right, that means that there's a positive relationship. Right? And since the sign of the correlation matches the direction of the relationship, then yes, R would be greater than 0. It would be positive 2. So that's a true statement. Okay. D, R would not change if we measured the lengths of the trout in centimeters instead of inches. Yeah. So let's explore what happens when we change the units of one of the variables. Yeah. So here I've got two variables, x, and I'm going to pretend this is in inches, 1, 2, 3, 4, 5. The response variable is just 1, 4, 9, 16, 25. This is squared values here. We'll do the analysis. We'll look at the correlation. It's 0.981. Yeah. Now what I'm going to do on the other tab is I'm going to change the explanatory from inches to centimeters. And to convert inches to centimeters, you multiply by 2.54. Okay. So the first value you see there is 2.54. The next one is 5.08. That's just 2 times 2.54, and etc. The last one is 12.7 because 5 times 2.54. Okay, we're not adjusting the y values at all. Okay, just the x values. Okay, here's our analysis. Here's the correlation. It is the exact same. It's 0.981. So again, because correlation is a unitless number, it doesn't matter what units we measure the variables in. Okay. So R would not change. That is true. It did not change. Okay. And I'm not going to demonstrate it again with the y variable, but if we change the units of the y variable, that's not going to affect the correlation either. It will stay the same. All right, so the false statement here is B. R is not measured in inches. Again, R is a unitless number. So actually, let me explain a little bit why it's a unitless number. And we're going to take a look at the formula used to calculate R. Okay. Let's take a picture of this. And done. Save. Insert. All right, so this is the formula for calculating R, the correlation. Okay, so notice that it involves adding and dividing, so it's kind of doing an average calculation. But the thing that it's adding up is these products here. Okay, this is saying take an x value, subtract its mean, divide by its standard deviation. Right. So this expression here represents a z-score of an x value, and this expression here represents a z-score of a y value. Z-scores are standardized values, right? They're in standard units. So it doesn't matter whether things were originally measured in inches or centimeters or pounds or kilograms. This formula converts everything to z-scores anyways. So the original units don't matter.